So, in the name of God, the compassionate, the merciful, this is the week 2 of our practice sessions of C++ TMP and template metaprogramming. In the previous week, I think we did, let me just go through the list of things that I have prepared. Find it. I think we did null, head, and last. Is that correct?
Mm-hmm.
Anyone? Right. Okay. Now, the data structure that we worked with is this guy, hidden in all sorts of, what is it? Comments. So now there is everyone's environment ready? Editors, compilers, yeah. Okay. Now, so you guys probably remember the gist of the story. So we have a struct list that is templatized over by runtime template parameters called exes, which is the kind of list of the items that we carry around in the at compile time, and we would like to provide a list library for this that is similar to the Haskell library. Now we have done append, postbend, head, last, and null. Now the next thing to do is the bang operator. So that's index. The one that, yes, index of Idris. So that's that takes a list and also an index. Then it gives us the entry at that index. So you are seeing part of the solution, unfortunately, here. That wasn't planned. Let's see whether I can take it out.
We will shield our eyes.
Good. So yeah, you have 3 minutes to implement that. Go.
Sorry, the bang.
Yes, the bang. And I will tell you that you would not be able to call it bang. So exclamation mark. Let's call it BB for the moment, and I'll tell you why. In the meantime, I'm going to have a few bites. One minute passed. Two minutes passed. Time's up. Yep. Who's done?
Kind of,
Okay,
I think.
okay, I'm gonna give you 2 more minutes then. Looks like no one is done. One minute past. Okay, who's done? Good. Rest? No. Okay. Okay, you can have 2 more minutes then.
What was the C++ in what's it called? In syntax for inline if else?
Right. You mean the ternary operator?
Yeah, I think so. It's
Right.
question mark.
It's condition. Better to put it in a parentheses. But the condition question mark, the then branch, colon, the else branch.
Okay, cool. Thank you.
Yeah, welcome.
Could have probably found it out myself, but I have a C++ expert right next to me, so.
No, don't worry. Don't worry. I'm not teaching you C++ here. I'm teaching you C++ TMP.
Fair, fair.
Okay, 1 minute past. Come on, guys.
Yeah.
Okay, we have 1 more. Great. Come on, this is now over. Right. Okay. Now, let's see. I would like to ask those who are stock to first tell us why they're stock. And I'm going to start with Daniel. Now let me just start my share and then enable you guys. Okay. Now, Daniel, show us why you stopped.
Well,
Sure.
I'll have to admit that I wasn't quite following what was going on since
Oh,
yeah.
you were
missed
not
out.
the
I missed out Monday's lecture. I can attend.
right. And you didn't manage to watch the recording.
I haven't seen any recording. Is
You're
it
not.
oh, was it
Is that-
already up? Because I had a look.
Yeah, I didn't send you the links, but I told you that I will do this every week. So
Yeah. Okay. No, that is
so
my
I
bad
think
then.
I did upload it the same day. I think so. Now maybe I'm wrong. Please double check. Okay, but anyway, so fine. You are excused if you couldn't do anything. But Mikhail, show us where you are stuck.
Yeah, I don't know C++ syntax so well, so I was
That's
just
okay.
stuck trying to iterate a list for some reason. I couldn't manage to figure.
That you shouldn't be stuck at
Yeah.
because we did that the last time.
I
Now
know.
now show us where you are. Just share it with us.
Yeah, I've erased everything. I'm starting over because
Oh, really?
what I had
Okay.
was starting to become too long for it to be an answer.
Okay. Well, that doesn't feel very well, but
Yeah.
that means that we have to go to Niels. Niels, please.
Yeah. I don't have because what we did previously I did on my laptop. But it's the same. It's the same problem I had last time before I had to go early. With or not go early, but with the unpacking
Okay.
thing,
Okay.
because I
So would you like to show us where you stuck?
yeah I can
Thank you.
see share my screen.
Okay. Now, so you're one. Okay. You're putting. Sorry. How are you?
I'm in for a template argument one. I don't know, like if I don't have this there, I'll get it can't find out what X is. Is it just because I have it in the wrong?
Yeah, that should be it, and you have to first introduce it.
I'm sorry.
But not there. So you usually,
Oh.
this is like Haskell, like Haskell lists. So consing is that you put the X before the X's. And if you want to have the X on line 11, you have to first introduce it on line 10. And you do that in the order usually that you want to have it. So yes. Okay. Now, so you want to have a function like this, which then, okay. Now, what you are getting down at the bottom is, so is this you trying to compile, or is this you? Have you saved
No,
it?
yeah, it just tells me
Okay.
I haven't. Yeah.
Right.
Into
Okay.
complaints.
So the error message that you get, can anyone demystify that error message for us? It's something that we did talk about last time, and Niels does remember that we talked about this, but he doesn't remember the solution that we proposed for it.
I think it matches first. The one matches on the auto.
Okay.
In the
Yes.
template.
Correct. Yes. indeed so.
Mm.
Indeed so. So the match is such that it starts from the very beginning, and therefore it tries to match you know, 1 with X, and then it takes X is to be an empty pack, and then it misses N. Right?
Yeah.
And with that, the typing, even if you would have provided another you know another argument on line 24 for B1, even if you had done that, then you know, that would have meant that it will try to fill the X's, and it would not make it to N. So yes, you need to put the, you know, you need to put the
And outermost.
well, yeah, that's part of it. Yes, okay, good. Now, right. Now, do you recall how we solved this problem for post-pend last week?
What problem?
Post pen.
We had a similar problem. You know, we can put the N at the very front, but
Oh
then
yeah, with because no, I don't remember.
okay. Now, putting the N in the front is not semantically correct, because we want to have the list, and they then say that I want this index of that list.
Yeah.
So in Haskell, you would say L bang bang the index, right? So the index comes after the list.
Yeah.
Now, so the ordering, you might get rid of that error message that you have. Well, by the way, the error message that you get is because you are doing a runtime if statement. So that, well, maybe not.
Yeah.
So you have to have a const expert comes after, and it's const expert. It's not const
It's expert.
Yes, but the const expert comes after the if.
Okay, so if const expert, yeah.
Now, fine. Now let's thank you very much for sharing. Let's see Jan's solution. Yeah.
Oh no, it's I realized it was wrong as I was writing this. So because I was
Okay.
trying to write a test.
Show us what is wrong with your solution.
Sure. It's a good question. I might have been using the wrong types. It's the first thing.
Okay.
I have a quick question.
Please.
Are they unlisted, the practical sessions? Because I'm looking on your channel now, and the latest videos is the session 3 part 1
Right.
on the introduction.
They are unlisted. So if you go to the mailing list, to the playlist, you should be able to find them.
Okay.
Right.
All right. So at first I had before I started sharing, I had the number call inside of the function.
Ah, okay.
And I realized that was wrong when I tried testing it. It started complaining. Meaning it gave me red arrows as a, I should write two. There we go.
Well, if it is not in the list, in the parameter list, so you're first of all, your line 48 is wrong. Because you're taking it up there as a non-type template parameter, and you're also trying to take it as an ordinary level
parameter, and that's wrong because I had it as a ordinary level parameter.
non-type template parameter.
Yeah, as in just like this.
Let's say for the moment, okay?
Should I go back
Yeah.
to this one?
No. Well, I would like you to learn the art of design exploration.
All right.
That's the reason why I'm calling on each and every one of you that is stuck to see whether you can defend your solutions. You know, if you can't defend it, then you should be able to unstick yourself. You shouldn't be stuck.
True.
Yeah.
So okay, defense of solution. Fair. Right
Okay.
now it's a bit messy. So I was thinking, since this is not at a type level, this one, I could recurse down it in a similar way. So XS's are part of the type level, I guess. And then the call to recurse down N was down here.
Okay.
Like so. Now it's complaining about something.
Right.
Because there's no matching function call to it.
But
it doesn't match on both of these. I
Well-
can't think the head of. Well, I could use the previous head function, couldn't I?
you can do that, yes,
Yeah.
but you can which is quite sensible. But if you don't want to do that, you have to first pass a list to BB, not a pack.
I can't make the pack into a list.
No, a pack is different from a list.
Okay.
So that would be list within angle brackets, X's, open open parentheses, close parentheses.
Oh god. Sorry. There.
And this is the type. Now you need to instantiate that. Okay.
There we go. Still complains.
Right. Well, can I just try to help you with line 54 first?
Yeah.
Go to the call of BB. Okay. Right. That thing is extra. Okay. Very good.
There. Still complains about something. Yeah, sorry, please.
Yeah. So
Instantiation.
in the
of function
instantiation
templates
function. Oh, let me just get rid of the Joe's. Okay. This is something. Right.
The call down there, I think. That makes this, since it uses this list here.
Right. What do you have? Your recursion doesn't have an end. Have you noticed that?
That is true. Yep.
Okay.
So I should have a case for a empty template.
Okay.
Uh,
But do you need that? Does that need to be templatized?
Not necessarily. But how would I untemplatize it?
Just remove your line. Well, not this one. The second overload.
Oh
So
yeah.
you remove line 50. You remove line 50, but not line 51.
Oh yeah. Of course, because they're in the same context. Yes.
And then your
should
second
be-
list needs to be empty.
Yep.
Okay. And what do you return then?
Empty list or error it should be, but
No.
Mm.
The thing is that, so if you go to, and this is where it's important to take a look into your Idris. You know, this bang thing
it's only defined
only works for when n is greater than the length of your list. Sorry, less than the length of your list.
Yeah.
Right.
Agreed.
Now Now,
No, I should probably
in
have
order-
included it on top.
right. In order to do that, n has to be a compile time parameter
Mm.
because you want to check that at compile time. Now, I haven't still told you how to do that, how to perform the check, right? But I think you now realize that this design doesn't work. Now, how to fix it, you can do that later. But at the moment, I just wanted you to come to this observation that this design doesn't work.
No, I think I realized that from watching Niels,
Mhm.
but I couldn't give a
Okay.
good explanation.
You
for
can
myself.
give, or you
Okay,
cannot.
I couldn't, but now I can.
You couldn't.
Mm.
Very good. Very good. James, show us yours, please.
Sure. Let me just delete some experimentation. Okay, so share.
Oh, I should stop sharing.
Yes.
Right.
It is, yeah. I think it's
Okay.
pretty much the same as Nils.
Right. Where does your so you put a okay.
Ignore this. This was me. I was trying to get an operator to trying to
Right,
get the square
okay.
bracket thing, but yes.
Okay, can
That's-
you right. So your recursion does have an end.
Yeah, so
but it's not all the time. So if I want to so your recursion ends when n is 0. Right?
yeah.
But what happens if you ask for an index which is out of bounds?
Well, if you ask for an index that's out of bounds,
Mm-hmm.
will that not be a template error?
It will be an instantiation error. Would you mind sharing with us that error, please?
Sure. Let's
Well, let's give it a pass case first.
okay. So I need BB.
Yes.
So there's my pass case.
Okay.
So that should build. Yeah. But then if I change it to 100,
Mm-hmm.
oh, that's squiggly. Then I get a failed no matching call to BB.
Right, let me get the right. So I would like to invite people to go through this, the error message. Can I just ask you to zen on the error message for a bit?
So it says, so it highlights this area here.
Yeah.
No matching function call to n-1
Uh-huh.
for x's for that. And I guess it says candidate template ignored, failed template argument deduction.
Right. Do you know
not
what
saying,
has happened?
Yeah, which
What
is
has
well, we've got, when you run out of parameters in your parameter pack,
Mm-hmm.
it isn't really able to match my only interface for BB. There's just no match, so it fails.
Mm-hmm. Mm-hmm. How do you pass that one?
Mm-hmm.
How do you provide it with that? And by the way, have you noticed that in your case, the index is now before your list. So on line 27, you put BB index, then the list.
Yeah.
Right. Now, so you understand that this is not the same ordering that we were trying to implement. We wanted to have the list, the BB, the index, right? Now let's put that aside. Let's put that aside. How do you make sure that you do have something for so you want to make sure that you're not going to get an out of bounds problem.
Do you want something? Because I would just
Right.
go.
How would you do that?
I would just add another case like that, and then I would. I don't. The problem is there's not really anything to return here.
Okay.
So
that
I mean,
that's-
because I don't know what, because I could, you know, something silly, but it's
no. This is not a solution. You do want a compile error,
yes.
but you want your compile error to make sense. Now, what is happening?
I see.
What is happening here at your error spew is that it has tried to perform the recursion. So, you know, the third line in the log is saying, okay, I started with 100, and then the pack 1, 2, 3. Then I got rid of the head. It became 99, 2, 3. Then it became I got rid of the head. It became 98 and 3, and then I don't know what to do. Right?
Yeah.
Now you're okay. That's not bad, but
that's my thought. But
okay.
Oh, I don't know if it. Yeah, that works.
Yeah,
I think because error out of bound. But if I get rid of this line, then oh no, I still get it.
Do you know why?
Because it's always going to run that.
Yes, because this is not a you see, what you have done is that you have produced a static assert that is not dependent on the second phase.
Yes, I need it to be. Can I just add? I don't know if I can just.
Do you really need that?
This?
Yes. I mean, no. Well, wait. What you can do with this is that you can say, okay, you can have a pack. No, that's not going to work. That's not going to work. You can have a pack, and the pack needs the ellipsis, okay, and then that in addition to a non-zero n.
I see.
Size t, yes, okay, yeah. So that would be right. List of what then?
List
n
of.
is fine. Okay.
Yep.
Now, what do you need to check in the static assert?
I need to check that. So I need to check whether, in this case, whether the list has anything in it.
Well,
And
whether
that n is no. Whether n is greater than the length of the list.
Well, no. What you want is to check. So you have already performed the recursion for when the list is non-empty in the previous case, in the previous overload. What you want is to check whether the pack is empty and that n is non-zero.
Okay, so that would be
that's capital X. Yes. Well, non-zero, or well, the list, the pack is empty, and the pack is empty.
Oh yeah, the pack is empty.
Okay. Now,
so like
this, please. Yeah. Compile this, please.
Yep.
Okay.
And then if I
Now
add the error back in.
Yes, yes, please.
Oh, sorry. There we go.
Okay.
Um,
Could you please show me where it makes it to your?
Mm.
I mean, it's now complaining because of the return type of this, I think. Because it's saying,
yes,
so
that's true.
it would probably be better to stick this static assert in here somewhere.
You can do that, but you see what you have done is that you have eliminated the possibility. No, you go on, show me what you want to do. That's a better idea. Now what would you like to assert in here? Because this is now a different game. And you would want to get rid of the what is it, the second overload.
This overload?
No, the second overload on line 25 to
one.
27. No, the one on,
yes.
on that, yes.
I see what you're doing.
Okay.
Out of bounds. I was hoping it would just assert this each time.
Of bounds? What would be? Yes, it will. It will, but the conditions are now wrong. That's the problem.
Are they? So n is greater than 0. I mean, this should be.
What you really want,
yeah,
is that n is greater than, so it's really out of bound. Now you know that your bound, you know that your bound is size of x is +1.
Yeah. So
right?
I guess that
now
should
this,
be a
this
1.
Static, well, this static, you can just put it the other way around. You can compare n against size of x's.
Oh yeah.
Yeah. Just help yourself with that.
Why is it? Oh, is that just because of this?
I don't know.
Static assertion failed due to the requirement that. Oh, is it because?
Would you mind saving it, please?
Yep. Press build just in case. The requirement that one unsigned long.
Oh, and yeah, well, you're statically asserting the other way around. So n has to be less than, strictly less than.
True. That makes a lot more sense.
Yeah. And wait,
yes.
wait. You're not still done. Is it?
No.
Is it? So I said strictly less than. And so you see the list that we are comparing against is of type x, x's. Right?
Yes.
Okay.
So I probably need a +1 somewhere.
Or less than or equal.
Yes.
Okay. Okay.
Good.
Now remove that one.
This seems to be working well. That builds.
Very good. Now
0,
now,
1, 2.
do on comment the line 28, please. Yes, okay. Now build.
And that will say.
Okay. Now
out of bound
the good
error.
thing, right? Okay. So that's good. Now, can you please scroll down in the log that you get?
Yeah.
Okay. Now, right. So you see, you get to see errors which relate to the out of bound assertion. And you also get to see error messages that relate, like the one that is at the very bottom of your page at the moment.
Yeah.
No, the one right above it, that relate to the recursion. Right. Now this is okay. This is okay because it still shows you where things go wrong. The trouble is that it's a bit of, you know, aftermath, because it has tried to get inside the function. So you get those messages because it has tried to get inside the function, and then it has failed.
What I'm thinking,
tell me.
sorry, is my gut reaction, although I can't remember how to do it, would to do one of there was a way of doing an anonymous template where you could add a condition. We didn't name
enable if.
I don't know if it was enable if, but there was
there
something where we did
if that I told you about, but there is. Thank you very much for leading that way. Right.
It was in that session, but I don't think it was enable if. You just had an expression in your templates.
Oh yes, that's right. You can.
And I
wanted
to put the condition there.
Very good. You can play around with your return statement and the comma operator, right? So yes, thank you very much for remembering that. I am now going to show you a solution that is easier than that.
No.
Yes. Okay.
I'm in disbelief.
Well, it's going to take a few moments. Don't worry. And it doesn't have a lot of pain. Now, let me share things with you. And I could have simply shown you the solution, and then you guys would have not learned how to unstick yourselves when you're stuck. But I specifically wanted you to first of all show me where you're stuck, and then I push you a few times to see whether you can manage, right? Because you should gradually grow the skill, right? I mean, I could have just shown you the solution and you see, okay, this is it, but you don't learn how to produce the solution. Now, first of all, my BB, where is it? Is a member function. Because, like the case of postbend, right, we want to write the list, then the BB, then the index. And, well, that is possible. One way for that to be possible is to make BB a member function, right? Now, so that's one thing. The thing that I was going to show you, and that was new, and that didn't require the trickery that James was talking about, is this linguistic support on line 27. Now, my BB now has two conditions that it requires. First of all, it requires that X is non-zero. Sorry, the pack is non-empty. And it also requires that N is less than or equal to the size of X's. Right? Now, this is only the function declaration. Does everyone follow this much of it? Okay. Now it's a good idea to take a look into the Idris Meta Idris kind of comments at the top. So X is, BB, given a literal type tie, is a meta function that takes a list of size n of ties, and then, well, this is not right. This has to be nat. Then a nat, and it returns an instance of that type. Okay. Are we all good with that? Very good. Now, one thing to notice here is that list itself has one set of template parameters. BB has another. And these two are independent. Now, that means that if we go to the implementation of BB, there are two sets of parameters here. There is this, which belongs to of template parameters. There is this, which belongs to list. There is this other one, which belongs to BB, and you can't put them on the same template parameter specification, right? Now, here's something that is even more funny. Well, it's funnier. This requires statement, requires clause that you see on line 106 is the one that you see here is here in, well, it's this one, which belongs to list, right? So that means that when you are doing, maybe this is just too large. Okay. That means that when you're doing the heading of list, the requires of list has to be there. Now, I haven't still told you what that is, but we'll get there, right? The other thing is that it's then as soon as you introduce the template parameters of BB, then and only then you can provide the requires clause of the BB part, and they are separate. You can't put them together, right? Now, okay, what's inside? Well, what's inside now? Remember, in here, in this BB member function, we have these requirements checked for us, both this and this, which you still don't know what it is, but we'll get to that. Both of these are checked. And in particular, we know that inside this function, we are dealing with a non-empty list. And we know that our n is not out of bound. So then the only thing that we need is to perform the recursion. Now, if n is 0, if it would have been that we had an x and then the x's pack, it would have been that we would return x's. Sorry, we would return x, right? Because the 0th index of a non-empty list is the head of it. Now, that leads us to this head thing, but within parentheses is something that you most likely were unfamiliar with. Unless you have done some C++ in the past, which I think most of you haven't, you don't know what the thing that is inside the parentheses is. So this keyword THIS, this is a pointer to the object that we're dealing with inside the class. So if you want to refer to the current object inside the class, you have a pointer to that, which is this. This is a keyword, THIS, right? Now, that keyword, like I said, that's a pointer. But we don't want to pass a pointer to, we don't want to pass a pointer to a list to head. We want to pass a list. So we have to dereference that pointer. How do we do that? By placing the star before, but come on, my highlighting is bad. But anyway, you get it. So let me see. This star does the dereferencing for us. It produces a reference to the current object rather than a pointer to it. And now that has the right type. It's a reference to a list, which means that we can also take a copy, which means that we can pass it to head. Are we good thus far? Daniel, are you lost?
Yeah, I missed out on the implementation of list and head and all that, so it's.
Oh, I see. Okay.
So I'm just trying to figure out that as we go.
Right.
But that's
right.
Other than that, I'm
Right. Right. Okay. Did you find the recording of the last session in the list?
No, I haven't found it. If you
Okay,
posted the playlist somewhere, then I will find it.
Well,
And
if
I
you go
just
to my
found it.
channel, you should be able to go to my playlists, and you should be able to see the playlist for this module.
Yes. All right.
Okay. But you will find it, I hope.
Yeah.
But if you fail to find it, please let me know.
Oh.
Now, so fine. So everyone else is already good with this. I take it. Yeah. Now, here is again something quite new. Now, so provided that we are dealing with a non-zero n, we need to perform recursion, right? Now, this much of it, I think you understand. You understand that there has to be a recursion, and you understand that you know this bit of the syntax. Let me put it on a separate line. The bit of the syntax that is on line 113. Everyone understands that much of it. Is that correct? Now, do you also understand that in order to perform this call, I need to work with the tail of the referencing of this? So let me put it on a separate line. So do you also understand the reason why we needed to do tail of the referencing of this on line 113? Do you understand that? Okay. Now here's the new thing. I needed this keyword template here because when the compiler performs this, and it wants to call a member function, you know, there's a dot here, right? If this is too small, I can make it bigger for James to also see it, right?
Oh, it's okay.
Now, it was okay. So you see there is a dot here, which is an endeavor for getting the member function call. The compiler does not know that this thing, the BB member function, is itself templatized. Therefore, we use this extra bit to say that, listen, the compiler, this function itself has a separate, takes separate template parameters. In order for us to be able to put this afterwards, come on. Let me again break it into a separate line. You know, in order for us to be able to pass template parameters to BB, we need to tell the compiler that this is a template, right? So I'm now going to put all of that back where they were. Okay, and right. So, are we all good?
Yeah.
Okay. Now it's time for a joke. Jan, you go first.
I don't have any prepared, but I have some memorized.
Okay.
So a farmer, he finds a magic lamp on his in his field. And he rubs it, and a genie emerges.
Okay.
And he says, I'll grant you any wish on the condition that your neighbor will get the same wish twice. And so the farmer says, take my eye.
Yeah. Okay, well, I don't want to be racist, but there are certain races that I can think would have said that.
Oh no, it's just a general farmer. I don't see it as a racist.
Okay, fine.
I've got a good one this week.
Tell me.
I went to a psychic the other day, and I asked her, am I going to go to prison in the future? And she said, no, I don't see in your future that you're going to go to prison. So I robbed her.
Right. Yeah, good one. Good one. It's so have you this is there is a picture that you can see for yourself on the internet. It's real. There is this guy who is a fortune teller, and so there is this session that people, so he had planned for a live session, and then there is this poster which says session cancelled due to unforeseen conditions. This is reality. The guy wasn't really joking. Right. Okay. Now let's see this thing in action. So, let me export auto. How many of them do I have? Let's see. Let's do 1, 2, 3. And then baby. 1, 2. Oh, this one should compile. It does. Let's make that 20. Now I get an error log, which you see in just one go tells me that the requirement fails. See the expression, I can't make this one bigger, can I? Oh yes, I can. Okay, it says that the expression n less than the size of x's, with n being 20 and x's being this, fails. And this is where you require that. You see? Now, what I'm trying to teach you here is that, correct, you can a lot of the times, actually use the static assert, and sometimes that's the only option, right? Sometimes that's the only option. Still, there is, if you don't want to use concepts, sometimes that's the only option with even with you know, the TMP, C++ TMP. But let's see, what was I trying to say? However, if you use the requires, which is a C++ 20 thing, I think, if I'm not mistaken, your error messages make even more sense because you get the error messages before getting inside the body of your function. Okay, that's what I'm trying to teach you. Let's get rid of this one. Now, here are a number of rhetoric questions to you guys. Right. And I'm going to start from James. Why did I not put auto X and then auto ellipsis X's here, by which I could have just simply disregarded this one?
Is it because you wanted to split your requires out? You wanted the
No.
So I feel like you could just put is unityped. I mean, it's because you want n to come after x's, isn't it?
I want n to come after X's. No,
No.
that's not related. No. Would you like to see it in action? And maybe then you can explain it to me.
Yeah.
Okay. Hello. Let's say that we don't quite care about the rest of it. Can you explain to me the error message? Maybe drop. I'm going to make this bigger. So, right. I think here at the top it should be.
Oh, the incomplete type.
Yes. Here's our struct list.
Yes. Why is it an incomplete type? Because you're an incomplete type if it doesn't have access to the definition, if you like, of a type. Then you get the incomplete type error.
No. Not just that. Not just that. Remember that this is a templatized, and I think that I got the your number one from Mikhail. Is that right? Mikhail, were you yawning?
I was stretching.
But not yawning.
As you were
No, I was holding in the yawn.
Eye stretching.
Yeah.
Okay, we'll do a camera check later. Don't worry.
So, can you go back to the question? Because yes. I feel like you asked a different question to what I was answering. Can you ask the question again?
I asked you why did we not enforce the non-emptiness of the list by assuming a first element for it anyway? And then I implemented that. I implemented that hypothetical solution for you, and now I got this error message, and I'm trying to get you to explain for me this error message. Now
So
here's
why
a
is it an
hint.
Yeah.
Here's a hint. Do you recall that I told you that template specialization need not to have anything in common?
Yes.
They are separate classes.
Yes.
That means that, in particular, this guy is different from when the X is not here. It's a separate class.
Yeah.
And what we have provided here is when there's only one pack here.
Yes.
Okay. If we want specifically to treat the one that has the one that has more than just this in it, we are dealing with a separate class. And we haven't introduced that separate class. So that means that if we wanted to insist that we want to take this design, we needed to duplicate this struct for when there is an X here before the X's.
But why didn't we have to do that for head, tail, null?
Because they were not member functions.
Oh, so it's because it's a oh.
Yes, because it's a member function. Those were free functions.
It's because it's a member function.
That's right.
Yeah, you see, I've not defined any member functions yet. I've been doing them all as free functions, which probably explains
right.
why.
Well, in your case, I explained it that in your case, the order of the parameters is not right. Okay. So, this is the act of design exploration. Okay. Is everyone following? Yeah. Okay, next question. I'm going to ask that from Mikhail. This is something that we have already answered. So I'm hoping that you can answer this one quickly. So why not take this n parameter as a value level parameter? Why should it be a type level or template level parameter?
Because we want to reference it within the grid.
Within the
in the code block, but I don't think that's it.
No, it's not. Let me just perform the undoing. Okay. So Jan had it as a type value level parameter, and I told him that, well, for that maybe you don't recall it. Jan, do you recall that yourself?
Yeah, I recall that it doesn't. The what's it called again? The recursion doesn't terminate. Was that it? Well, I mean, it did. No, that's not it. Something went wrong with the call. Jesus. No.
Okay, well, you'll watch the recording later.
Yes,
but here is my my response at this point, because I don't want you to be confused. So I'm going to give you the response once more. You see this condition. This condition needs to be checked at compile time.
Yes.
Which means that this n thing needs to exist at compile time. Which means that if we take it here, well, in fact, we can move this requires clause to after this, so we can swap the lines 108 and 109. That's no problem.
Mm.
But a value level n will not be able to participate in that require statement because that's not a compiled time n.
Makes sense.
Right.
Perfectly makes
So
sense.
that's
Thank
that.
you so much.
Thank you. Now, the third one we have also responded, Niels.
Mm.
Why did we not go for this one, this design? Oh, everyone's stretching. We really need another joke. But let me first get you to answer this question then.
Well, list, is it because why we're not using
Well, it has to do with the way we want to call it. So, you know, what we want is to be able to say BB of L and N, right? This is roughly, if we want that, then this is what we want.
yeah.
First of all, this is not syntax, so we would have had to do decrement type of L and N. Or if we want to really drop that, then we would have done this. But this is not right. What's wrong with this?
It's still expecting it can't find or figure out what n is.
And will match
Roughly.
against excess.
Yeah.
Roughly, yeah. And the other thing is that, you know, the syntax that we're after to simulate is this in Haskell, right? So N has to come after L,
Mm.
right? So that's the reason. Now, here's the final one, and I think that you can't answer this one. So why not just call BB bang bang?
Is it because bang is already a protected operator?
Keyword.
Well, let me show it in action to you.
Negation.
Yeah, you do negation of negation.
Does it just
I
convert
think I
something to
know
a Boolean?
why.
Go on.
I think
Go
the
on,
reason is because you can't do an auto for an operator overload for the return type.
That's not right. No, that's not
Because that was the error I got.
Well, let me see whether I can. Let me see. So, overloaded. Come on, what's happening? TTP reference. So, first of all, the list of C++ overloads, sorry, C++ operators is fixed, right? You are not allowed to, I think there is, yeah, restrictions. Right. Restrictions. The first one is that you can't overload these particular, operators. The scope resolution, the member access, the member access through a pointer, and the ternary. Right, that's one thing. The other thing is that you're not allowed to provide new operators. You can only overload the existing operators of the language, right? And if you take a look at the existing operators, there is no bang bang.
Oh yeah, I did the square brackets. That's what I was trying to do.
Right, right, okay.
The other problem is that you can't get a template like n that I could find. The input had to be on the value space.
Well, I can help you with that one, but let's set that aside. Right? Now, fine. So that's the reason. Now let's have another joke. Who's remaining? Daniel.
Let's see if I can think of one. There was a farmers related joke as well. I remembered when Jan told his.
Perfect.
Oh yeah, yeah. It's this is a terrible one. How do you marry a farmer's girl? You have
I've
a
never
tractor.
tried.
Hmm?
What was it, sorry?
You have a tractor.
You have a track.
You have to
Mhm.
attract
Attracted
her.
her. Yeah, I've attracted her. Yeah, okay. Good.
Terrible. I know.
No, it was good.
Oh, very good, very good.
Yeah. Okay, guys. Now, so we have spent, I think, our entire time on this BB thing. You know, this is beyond my expectation. We have gone through a lot of details, and I was wondering how much of this did you enjoy? I mean, I can go way faster as I usually go. But I feel like you guys deserve a very detailed kind of
Explanation.
no, actually, not just the explanation, a very detailed experience with the matter, because you guys will build the skills in a much deeper level. So I usually in 2 hours, so let me see. In 2 hours, I usually teach null, head, last, BB, append, and map. Right? And now we have had almost 2 sessions, which is 3 hours, and we have only covered these. Now, please help me finish this one as well. Append.
Yes.
Right. Now, so the idea is that we do the plus plus. Oh, one thing I failed to show you is the address code for index. So right. So the address version of Bang Bang is called index. And you see, address being a dependently typed language, right? It can make sure that you will never get an out of bound error at compile time. By doing what? By instead of receiving a len here, receiving a fin of len. Right? Now, this is a much more advanced solution than what we did with requires, because this is at the type level. And if we manage, and I'm really hoping that we do manage to make it to later on when we do things like well, some of the later functions, you'll get to see that indeed some of the things that are possible to be enforced at the type level cannot be enforced even with requires. Because the type theory that is provided here is richer. Right? Now, it's always a good idea to take a look at the Idris implementation when you are performing, template metaprogramming in C++. If there is an equivalent Idris. If there isn't, it's a good idea that you implement your solution in Idris and then try to see whether you can have the same in C++ thing. But now let's go to append. I don't think that there is a. Okay. Here is the address solution for plus plus. It's a simple recursion by deconstruction of the head of the left operand, right? Okay, can you all understand this? The lines 188 to 190. Yeah. Okay. Now let's go do the same in C++ and let's call it append. Okay. You have let's say 5 minutes. One minute past. I'll be right back. Okay, time's up. Who's done?
Maybe.
Oh no. Come on,
Maybe.
boys. Okay,
need to
one more
test it.
time. One more minute.
Oh. Just supposed to put the list together, right?
Yes. Yes,
Okay,
correct.
then I'm done, I think.
Okay, very good. So you see, like, you want to see the answer? Oh, not here. Okay, fine. There. Okay, Mikhail, do you want to show us your solution, please? I'm going to stop my share.
Sure. Green 2, yeah, okay. This thingy.
Very good. Very good. That's you using the more powerful tool that you have in C++ TMP. Very good. Can everyone follow? Oh,
Oh,
okay. Well, that's fine. That's fine. I'll just.
I can bring it back.
Yeah, that's a good idea. Maybe you should do that. Or maybe just you know, make the font larger a bit.
Yeah, sure. Okay, I'm not sure what I'm making larger.
Maybe it's Control Plus.
Yeah, but it didn't do anything.
Maybe it's Control with drag up. The
You can
scroll up.
zoom on the trackpad on the Mac.
On the Mac.
Yeah, I don't know about Windows, but C-Line allows
that-
you to just zoom it that way.
Yeah.
That's fine. That's fine. Don't worry. Don't bother. Don't bother. Can everyone understand what Mikhail is showing?
Yeah.
Is there anyone who can't understand it? No. Okay, very well. Thank you very much, Mikhail. Okay. Now, let me bring up my solution, and then we'll discuss details. Okay, this is the address, which performs the recursion, which is the strongest thing that it can do. We can do a better solution in C++ or a readily made solution in C++. So let's see, append. Right. So this is the recursive version of what Mikhail just showed us, and it's relatively like a literal translation of what we got in the address version. Right, you perform a recursion with an empty list. There's nothing to recurse on. You just return the y's. If your list of if your x's list is not empty, then you know it has to have a head. What you do is that you append the head to the result of appending the rest of your x's with y's. And my highlighting is also I need to change the color. Okay. Now, but in C++, this version is better because you now have a more powerful solution. Sorry, you have more powerful linguistic support. Right. So that's that. Okay, thank you very much. That was excellent. Shall we go for who hasn't told us a joke? Let's see. Mikhail, have you not?
I have not, but I've
Okay, tell us a joke then.
I've not got one prepared either, so
Oh, okay. Well, Neil, did you tell us a joke today?
I can.
Yes, please.
Did you hear about the fire at the shoe factory?
No.
Many souls were lost.
Oh no.
Right. Very good one. Very good one. Yeah. Yeah. Yeah, you should tell that to your pastor. Do you have one? Yeah. Okay. Oh, by the way, guys, what was it, sorry?
No, it was nothing. Don't worry.
Okay. But by the way, is next Tuesday a day off in Norway? The All Saints Day? Or maybe the next, maybe it's the Wednesday. I don't know. It really depends on which Christian.
No, I think that's a Catholic holiday.
Right. Okay. And so
Norway is not Catholic.
Yeah, we're Protestant.
it's not. Ah,
No.
I see. Okay. I see.
But
Okay,
if you want
well,
to take a holiday, that's okay.
Yeah.
no, that's not what I was
Say less.
I was suggesting. That's not what I was suggesting. But let's take that seriously. Do you guys prefer that we take a day off, or do you? I mean, are you just tired of seeing me all the time, or is it that you want to go?
I think
I am
it's good.
tired in general, but not of you, Hussein.
Okay, good. Thank you. I take that as a compliment. Okay.
I'd rather that it wasn't cancelled, because it's these 10 a.m. lectures are what massively increases my chance of getting out of bed before 12.
I see. Okay.
So they're quite good things to have.
Okay. Okay.
So I'd
Very
probably
good.
be more sad if I ended up with my alarm going off and me missing it, and
Right. Okay. Well, then we'll not. Okay. Fine. Now we have 2 minutes. Shall we attack map? Oh no, I think that one is going to take a long time.
yeah.
Nah, let's do it.
Can you do?
Let's do it.
No. Yeah.
Okay. Okay.
Okay.
Then how many minutes do I give you? Like I give
Can you tell me how I give what the type of a function? How?
Oh, I will show you.
Yeah.
That's a very good question. That's a very good question. I will show you the map of Idris.
Oh, I meant like in, I don't know how to, in C++.
It's like you in the angle brackets, you put like T for the sorry. What was that? What was that? Is that balloons?
I think that's like the partying. Yeah.
What anyway?
Yeah.
You put like a T and then in brackets Q, and that would be a function that takes in a Q and returns a T.
Well, let me.
Oh,
I think I know where you get stuck. Let me show you my version. This is map. Yes. Yeah. So the easiest way. Yeah, the easiest way to do it. Ah, gosh. I didn't want to show you the solution.
Good. A little padding.
Yeah. The easiest way to do that is to, suppose that, the function will be of some type name, and you just don't check it.
Mm.
So you take the function as an argument of a type that is on the compiler to resolute. That's the easiest way. Right. Now, okay, I'm going to stop my share because that, if I don't, then you will see the solution.
Huh. Did we make the tail function last time? Because I don't have it.
We did, I think.
I didn't have it either. So but I
Oh,
wrote it just now.
Yeah, I guess
we didn't do tail. I'm surprised.
I think we ended at last. No,
Oh, I'm sorry.
Oh,
But anyway, we don't need so the thing is that we don't need tail. But anyway, I mean, do what you think is right, and we'll discuss it.
Okay, so I'm not using tail then.
As you wish. The thing that you need to do is to defend your solution, and your solution should roughly go with what you can see in Idris. And as you can see, there is no tail.
Yeah.
What happened? Sorry. Apologies. What's that? Come on. What's happening? Why is it? Let's say you have 1 more minute. Anyone done?
Think so?
Very good. Would you mind sharing your solution with us, please?
Yeah.
Okay.
So here's the. I'm making a new list with the first element, and then I'm using the plus
Append it,
operator.
right, okay.
Yeah, with the map of the rest of the list with the function.
Right. Okay. Have you compiled this?
I haven't tested.
Okay. Do you know how to pass a function to a? Do you know the syntax for?
I was thinking I could just do write f.
Well, but where is it? Ah, that one. Okay.
No, it gives me an error. It's not. Initialization of function template specification. Function parameter f with unknown value cannot be used in auto constant expression.
Mm-hmm. So your function over there, that function that you're passing is not const expert.
Oh, so
Okay. Have you saved?
yeah.
Okay.
Is it getting confused because f?
No, that shouldn't be any problem.
Oh. Initialization requested here. Int times int.
Ah. So. No, it's not those. It's not those.
Okay.
Not those. Maybe the quickest way to proceed is for me to show my solution, especially because we are over time. So thank you very much. Now I'm going to share my solution. Okay. Now, so here's my solution. My solution is roughly the same as what the Niels was showing. Forget about these two lines. Just focus on what's here. Now the recursion, in the recursion, I'm passing f of x, and then I'm mapping f to the rest, and then I'm performing a prepend, right? Now I think this much of it was roughly the same as that of Niels, right? Now, so this is my implementation of the function is the same, but here's how I use it. So oh, this is the applicative. Right. Here's how I use it. So I pass a function, sorry, a list, and then a lambda expression. So this is the syntax for a lambda expression. Let me bigger for you. So this thing on line 75 is a lambda that doesn't capture anything. So that's the reason why there's nothing in the square brackets. It takes an x of a given type. It doesn't really care about the type that it takes. And then it returns x times 2. Right? Now this thing gives rise to a constant enough expression so that f of x is now on line 170 of mine is now a constant. Right now, so forget about the requires for a moment. An easier way to do the same is using what is called abbreviated notation for C++ template metaprograms, metafunction. So we can do the same, the exact same thing by, instead of giving it a type name f here, we just call it an auto. And it's for the compiler to figure out what the type of that thing is. So we just put an auto here, and there is nothing above here on the line 174 in comparison to the line 166. So f has no type in the template specification. It's just auto, right? Now, it's even easier to do map without recursion, because in C++ TMP, we have the entire pack readily available to us. So we can just unpack it or expand it like this.
Huh.
Yeah, and it's auto. That's what there is. Now, a bit of explanation about the requires, and that would be the end of this session. Now, what we are requiring here, there is this function is invocable v, right? There is this meta function, sorry. Is invocable is, maybe I should show it to you. On the way. Here's invocable R. Okay, let's see. The same ballpark. So is invocable is a meta function in the C++ TMP community that is available by the standard. Well, from the standard by in the header type traits. Now this thing checks to see whether your function is invocable in a particular way. And what we want it for is here that the type of function f, that we have no name for it at the moment, so it's now auto, right? The type is auto, so we need to acquire it. That's why we need to have the decal typing. Is invocable for every x that is in the list. And we have to expand that pack. Right? Now here is finally where we get back to the condition that I had taken away from you for a long time. This one. Now, in this condition, where is it? Sorry. In this condition, what I'm saying is that f should be applicable or invocable to every instance x. This would have been really required if the x's had different types. Otherwise, just invocability of f to one of them would have sufficed. Because the rest are of the same type. Now, a moment of truth. When you do, when you have a pack like this, auto dot dot dot, there is no restriction on the x's to be of the same type. They can be of different literal types. Now, in order for us to really enforce the sameness, I have worked out this this meta function. Well, it's not a meta function, it's just a constant eval function, right? Which takes a pack and gives us a Boolean on whether or not the pack are all of the same type. Now we can start the next session by going through that. I think we're already way over time, so we shouldn't go into. Now, one thing, if we drop that, everything will work, but it will no longer be the same as the vector of Idris. And if we want to do this sort of thing in Idris, we need to go through all that pain that we had to go through when we wanted to do the statically type the type safe printf, which is quite a hassle because the linguistic support for that is quite low. Now, James seems very confused.
Just at that last, if you want, what was difficult in Idris?
Well, do you recall how much of a hassle it was to get a type safe printf in Idris?
Yeah, but that's a little bit different because you could just say this is a list of for all a.a.
Yeah.
That's Haskell, I know. And then you can have any type in the list. And then you can unpack that list as long as the function is also a rank n and just use it with map.
Well, that's not the Idris vect, first of all.
No, but
not,
I imagine there are rank n types in Idris.
That's actually template Haskell, it's not Haskell itself.
No, it's not. It is not template Haskell rank n types. Not at all.
Maybe I'm missing something. Maybe we should
because you can say things like, I can type it.
Well, let me just dismiss everyone else and then we'll discuss it.